Hello, my name is Mr. Hlumwana PE. Today I'll be taking you through integration. So we will start from the most basic formula of integration, which is given as integral of x to the power n dx. So the solution to this formula is as follows: x to the power n plus 1 over n plus 1 plus c. So how can we apply this formula? If we have something like x to the power 5 dx, so here we can see that our n is 5. Therefore, we will have x to the power 5 plus 1 over 5 plus 1 plus c. So 5 plus 1 is 6. So the final answer will work out as x to the power 6 plus c. So this is the most basic formula of integration. So we can carry on and look at other formulas of integration, because of course this is the most simplest of which this type of question you will not be asked in a test. So let's look at this second formula. F prime f of x to the power n dx. So here you have f of x, which is raised to the power n, and on the side sits exactly its derivative. So how can we apply this formula? The solution to this formula is as follows: f of x n plus 1 over n plus 1 plus c. So meaning that if you have an integral where there is f of x and on the side sits exactly its derivative, what you do is you just write f of x to the power n plus 1 over n plus 1. And then of course plus c. So let's look at an example. If we have an integral of 2x and x squared plus 1 to the power 4 dx. So the first thing that we can realize here is that our f of x in this case is x to the power 2 plus 1. Our f prime of x is equal to 2x. So we can see that our f of x is x to the power 2 plus 1, and our f prime is 2x, so it means that it matches exactly the formula. So the formula can fit exactly. So what we can do from here, the solution to this will be our n, because our n is 4 here. So 4 plus 1 is 5, divided by 5 plus c. So that is the final answer to this integral. So this will be equal to that because it matches exactly the formula. Of course, there's another method that we can look at for integrating this type of a problem. So there is another technique which is known as U substitution. U substitution. U substitution also has a formula which is U du equals to u to the power n plus 1 divided by n plus 1 plus c. So we can look at this problem that we did here using the other formula, formula number 2. So we can say this is number 3. Then that question was 2x x squared plus 1 all to the power 4 dx. So this formula number 2 and u substitution, they work out to the same answer, but the way they are applied is a bit different. So in this case, we can let our u be equal to x to the power 2 plus 1. Then we can differentiate u. Then we say du dx gives 2x. Then we can make the x subject of the formula. So dx will be equal to du over 2x. Then we can go and substitute back into our problem, which was integral of 2x. Instead of writing x squared plus 1, now we'll replace it by u to the power 4. Then we will also replace dx by du over 2x. Then we can see that this 2x and this 2x can cancel. Then we are left with u to the power 4 du. Then if we apply the u substitution formula, we end up having u to the power, because our n now is 4, so 4 plus 1 is 5 over 5 plus c. Then because we were working with x variables, we have to substitute back our u, which was x squared plus 1 to the power 5 plus c over 5. So these answers are the same. So u substitution may seem to be a little bit longer, but it always works perfectly. So we can look at more examples. So if we have an integral of x squared, then x to the power 3 plus 4 to the power 3 dx. So if we apply formula number 2, which was f prime dx, which works out to be plus c. So this formula says that on the side they must sit exactly the derivative of f of x. So in this case, our f of x is equal to x to the power 3 plus 4. Then our f prime will be 3x squared when we differentiate x to the power 3. Then we can see that on our question there, the derivative of f of x is not exactly as the way we want it. So we can multiply x squared by 3 by rewriting. Then we have 3x squared plus 4 to the power 3 dx. So because we have multiplied by 3, so to be mathematically correct, we have to divide by 3, because 3 divided by 3 is 1. So now this part inside here, it fits the formula. So the solution to this, of course, 1 over 3 is outside the integral, which is more like a constant. So we'll have 1 over 3. Then our f of x is x to the power 3 plus 4. Our n is 3. So 3 plus 1 is 4 over 4 plus c. And this can be simplified because 1 over 3, we can multiply the 3 and the 4 in the denominator to give us 1 over 12. Then we end up having x to the power 3 plus 4 to the power 4 plus c. So we can, as we have done on the previous, like in the previous example, we can also look at how we can solve this by u substitution. By u substitution, of course, we should get the same answer. So the answer was 1 over 12 x to the power 3 plus 4 to the power all to the power 4 plus c. So we should get the same answer, and when we are using u substitution. So the question was x to the power 2 x to the power 3 plus 4 all to the power 3 dx. So by u substitution, we say u equals to x to the power 3 plus 4. Then when we differentiate u, we say du over dx, which gives 3x squared. Then if we make the x subject of the formula, we end up having du over 3x squared. So what we need to do, we need to go and replace and rearrange our problem. So the integral is still there, x squared is still there. What we need to do is to replace u. So we put u here instead of writing x to the power 3 plus 4. It's u to the power 3. Now we also replace dx by du over 3x squared. We can see that now x squared and x squared cancels out. Then we are left with u to the power 3 over 3 du. We can also take 1 over 3 outside of the integral du. Now we can apply the u formula, which will work out as 1 over 3, it's outside the integral, which will be u to the power 4 over 4 plus c. Then 3 and 4 at the denominator can multiply each other to give us 12, then u to the power 4 plus c. And what we need to do is to make sure that we go back to the variables that of the question, which were x variables. 1 over 12, we substitute back with x to the power 3 plus 4 to the power 4 plus c. So now so far we have been looking at x variables. So let's see if we can be able to apply these formulas in trigonometric functions. So if we have cos x and sine squared x dx. So sine squared x can also be written as sine x all to the power 2 dx. So we can make this to be our f of x, and then 2 can be our n, and then we can say this is our f prime, so that it can match this formula, this one. So if f of x is equal to sine x, then f prime is equal to cos x, then we can see that this formula, which works out can be easily applied, because our n is 2 in this case. Therefore, the integral of cos x sine x to the power all to the power 2 dx can be simply sine x all to the power 3 over 3 plus c. Of course, this can also be written as sine to the power 3 x over 3 plus c. As we have done like in the previous problems, we said that u substitution can always work. So we will always use the other formula and u substitution. So the equation was cos x and sine x all to the power 2. This was after it was simplified, because of course it was given as sine squared x. So when we apply u substitution, we can let u be sine x, then du over dx. When we differentiate the sign, we get cos x. When we make the x subject of the formula, we get du over cos x. Then we'll go back and substitute into our original problem. Cos x will remain as it was. Sin x can be replaced by u. Then u to the power 2. Dx can be replaced as the x can be replaced by du over cos x. Then we can see that cos x and cos x can cancel. Then we are left with u squared du. Applying the u formula is u to the power n du, which gives n plus 1 over n plus 1 plus c. So our n is 2. So the answer will be u, and 2 plus 1 is 3 over 3 plus c. So now we can replace back u by sine x. Sine x to the power 3 over 3 plus c. This also can be written like this, x plus c. So that is how to apply u substitution when we have trigonometric functions. So we can look at another example where we have cos 4x sine to the power 3 4x dx. So the best way when dealing with trigonometric functions, if you are having sine to the power 3 4x, it's better to write it in this form first before you can carry your integration. So if we want to apply this formula here, so we can let our f of x be equal to sine 4x. Then when we differentiate sine 4x, it gives us 4 cos 4x. So we can see that in our given problem, according to the formula, it says that we should have a correct derivative. The derivative of sine is cos, but in this case we have sine 4x, which the derivative is 4 cos 4x. So we must make sure that on the side sits exactly the correct derivative. So we can multiply cos 4x by 4 to get cos 4x, and then sine 4x all to the power 3 dx. Because we have multiplied by 4, we need to fix our mistake because we need to be mathematically correct. So we have to divide by 4. Then when we look inside here, we can see that it matches exactly the formula. This formula is exactly matched. So therefore 1 over 4, it's outside the integral, it's a constant. So our f of x, it's sine 4x. So we will end up having sine 4x. Our n is 3 to the power n plus 1. So 3 plus 1 is 4 over 4 plus c. Then 4 times 4 is 16. We end up having 1 over 4 sine 4x to the power 4 plus c, which we can also rewrite as 4 sine 4x plus c. And of course, here we can also use substitution. So the question was cos 4x sine 4x. So if we check here, the technique in this one is that after you differentiate f of x in this step, you realize that the way the integral was given, like here, there is no 4x, there is no 4x, there is no 4 cos 4x. So we put the 4 here. Then this technique is called compensation, where we also divide it outside, then by multiplying by 1 over 4. So when we are using u substitution, there's no need to do that. U substitution works directly to the answer. So we can let u be equal to sine 4x. We differentiate sine 4x, we get du over dx, which gives us 4 cos 4x. Then we make dx subject of the formula. Then we have du over 4 cos 4x. So what we do, like we did in the previous example, cos 4x, we leave it as it is. We replace sine 4x by u. Then we have u to the power 3. We replace dx by du over 4 cos 4x. So we can see that cos 4x and cos 4x are cancelling out. And then we are left with u to the power 3 du over 4. We can take 1 over 4 to be outside the integral, and then we have du. That is just rewriting. Then this can give 1 over 4 when we integrate by a u formula, which will give u to the power 4 over 4 plus c. Then we end up having 1 over 16 u to the power 4 plus c, but we know that our u was sine 4x, so the final answer works out as sine to the power 4x plus c, which is exactly what we got here. So these two formulas, they give exactly the same answers. So we can look at one more problem where we are still looking at trigonometry, but this time around we are no longer looking at cos and sine. Let's look at 4 sec squared 2x tan to the power 3 2x dx. So in this case, actually here the key is to make sure that the one that you pick to be your f of x, or if you are using u substitution, it must give you the, when you differentiate it, it must give you exactly what is on the side. So for example, if we take u as tan 2x, we know that when we differentiate tan 2x, du over dx will be 2 sec squared 2x. So it is advisable to take tan 2x as our u, because if, for example, if we can take u as sec 2x, we know that when we differentiate this, it won't give us tan, because the derivative of a sec is actually going to give us 2 sec 2x times tan 2x. So this will not lead to the answer. So we are going to take our u as tan 2x. So this one we can rewrite it as tan 2x to the power 3 dx. Then we let our u to be tan 2x. Then we differentiate tan 2x, which is du dx, give us 2 sec squared. So the derivative of 10x, we know that is sec squared. So the derivative of tan 2x will be 2 sec squared 2x by differentiation. Like we did previously, we make dx subject of the formula, then we end up having du over 2 sec squared 2x. So here, go back and substitute in our original problem, which was 4 sec squared. We don't replace it, we leave it as it is sec squared 2x. What we replace is our tan 2x. We replace by u to the power 3. We also replace dx by du over 2 sec squared 2x. Then we can see that sec squared 2x and sec squared 2x will cancel out. Then we can take 4 over 2 outside the integral, and we're left with u to the power 3 du. So 4 over 2 is simply 2 u to the power 3 du. When we apply du formula here, we end up having 2 u to the power, our n is 3, so it's going to be 3 plus 1, so it will be u to the power 3 plus 1 is 4 over 4 plus c. 2 over 4 is 1 over 2 u to the power 4 plus c. Then we can replace our u by tan 2x. So 1 over 2, it's a constant. We replace our u by tan 2x to the power 4 plus c. So that is the final answer. You can also check it by applying this formula. So you can go and try and apply this formula and see if you will be able to get to the same answer. So that is with integration. We will look at other more problems and more complex. So the purpose was this video was to explain and bring clarity on some of the difficulties that students have on integration. Thank you for tuning into my channel, and please do subscribe. Subscribing on YouTube does not require anything. You just hit the subscribe button. Thank you very much.